next problem on DFA construction under the pattern recognition problem. So suppose I want to build a DFA for the language L equals to the set of all strings of AB except containing the substring AAB. So for this kind of problem, I have to first construct the machine for containing the substring AAB, and then I have to complement the final state to non-final state and non-final state to final state. So let us see how to do this. I am starting with the start state Q0. I am constructing for containing the substring AAB. So Q0 is my start state. For each of the input alphabet of AAB, it has to change the state. So Q0 on A goes to Q1, Q1 on A goes to Q2, and Q2 on B goes to Q3. Now since it is containing the substring, so Q3 becomes final state and the remaining state becomes the non-final state. But since I want the machine for not containing this except containing AAB, so this final state becomes non-final state and non-final state becomes final state. So this will be the these will be final state and Q3 will not be the final state. So now the remaining transitions should be completed. So if it starts with AAB, it will be accepted in the original, but here it should be rejected. And Q0 on A, it is going to Q1. Q0 on B, it should remain in the same state because it is not having AAB. It has not started, so it should be in the start state itself. Then Q0 on AB is over. Q1 on A is there. Q1 on B. If it is B, again it has to go for reading AAB. So you have to go back to the start state. So Q1 on A is there, Q1 on B is there. Now Q2 on B is there, Q2 on A. If it is A, you go back to the state Q1 where you have already read one. So now still one alphabet is A. So next A, next B, it should go to the Q3 state. Now, so Q2 on AB is over. Then Q3 on AB. If it is containing AAB, so once I get after AAB anything, I should remain in the same state. So it will be a self loop on the input AB for the state Q3. So now for every state on every alphabet, I have a next state. So this is the machine for the required problem. We'll go for the next. Build a DFA for the following language. So L is A B raised to 3 W B square, where W belongs to A comma B whole star. So the minimum string is A B raised to 3 B raised to 2. So that means B raised to 5. So I start with the Q0 state. I should have 1A. Then I change the state to Q1. Then 3 B's. 1B, again B, Q3, again B, B cube is over. Next is another 2 B's. So 1B, 5, another B, 2, 6. So this has to be my final state. Now in between three B's, I can have any number of A's or B's. So if I have any number of A's or B's, I have to give a self loop here. But here already B transition is there. So on A, I can give self loop. Now on B, I have already transitions. So now, so if the string is A, B raised to 3, A, B, B raised to 2. That should also be accepted. So A, B cube, A, B, and again B, B. So that should be accepted. So for Q5 you have already over. So just a minute. So for Q5, if I get A, I have to go back to the previous state until I again terminate by 2B. So this will be my A. So if it is A, B, 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 B. So for Q5 on A as well as on B, I have transition. So now if I reach Q6 state and if I again have B's, so it is suppose the string is A, B cube. This W could be empty. So B rise to, suppose here, if W is non-empty, it has to be terminated by 2B's. So I can put a self loop here because it is still having the last two B's only. And on A, if I have A, I should go back to the Q4 state to get another two B's at the end. So on this side, the transitions are over. Now, if the string is starting with A, I have the transition from Q0 to Q1. If it is starting with B, then I should not go to the final state. So I should go to a trap state. So I will write here Q7, and any trap state is a non-final self-loop state. So on all the input alphabets, it will be there in the same state. There should not be a path from this trap state to the final state. Now for Q1, I have to have after A 3 B's. If it is again A, I should go back to the trap state here on A. Again here from Q2 also, if it is A, I have to go to the trap state. For Q3 also, I have to go to the trap state. So it has to start with A, B, B, B. Now for Q4 after A, B, 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 I can have anything here. So this is a machine for the required problem. So finally, you have to conclude by writing all the 5 parameters Q, sigma, delta, Q0, F, where Q is equal to Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7. Sigma is AB. Delta is as shown in the transition diagram, and F is equal to Q6. So we'll see one more problem on the pattern recognition. Build a DFA for L equals to AWA, which means it has to start with the A and end with the A with minimum 2 alphabets in the language. So I start with the Q0. The minimum string is AA. So on A, I'll go to the state Q1. On one more A, I go to the state Q2. So AA is the minimum string, so it has to be accepted. So Q2 has to be the acceptance state. If the string starts with B, it means it has to be rejected. So you write a transition to the trap state. So Q3 here, is a trap state, which is a non-final self-loop state on all the input alphabets. Now it has started with A. In between, it can have any number of B's. So it will be a self-loop on B for the state Q1. So for Q1, I have transition from A and B. For Q2, if it is having after A, I can have any again A's. It is still ending with A, so it has to be a self loop. If suppose the string is A, B, A, then on B from Q2, it has to go to Q1 state, and if it is again B, it has not terminated by B, so it should not take to the final state. So it is still in the state Q1, which is a non-final state. If it finds A, you go to the final state, which indicates it has started with A and ended with A. So this is the construction for the required language. So in the next video, we will see the second kind of problems on DFA construction. Thank you.